Hello and welcome to this presentation session. My name is Mehdi Zeinali. I'm working as a research assistant at Institute for Digital Communication under supervision of Professor John Thompson. My main research area is working on communication aspect of smart grid. This project is a part of a European project which is called Advantage, and mainly the aim of this research project is considering advanced communications and information processing for smart grids. I will start with a short description of smart grid technology, and then I will introduce the communication protocols and technology that we are using in different parts of the smart grids. Then I will focus on what is the next generation of wireless communication systems and how we can integrate our applications in a smart grid with the next generation of wireless communication systems. As you can see here, in this short movie, the current communications, it seems that, yeah, what's happened? Okay. As you can see, in current power grids that as now we are using, it's designed during last century in a one direction from the utilities to the consumers to provide the simple delivery energy but without any information from the consumer side, and it makes very hard to overcome any change or rising of energy demand. But during last few years, it's introduced new technology that it allows us to exchange the information and electricity between the utilities and the consumers. And also, this is a complex system that is combined from the automation systems, control system, communication systems, and it allows us to at the same time deliver the energy very efficiently, reliable, and secure. But at the same time, it allows us to facilitate the integrate the new resource of energy such as the wind, solar, and wave. That maybe it's possible to see here. And also the informations that it's acquired from, we collect from the consumer side allows us to predict the amount of energy that we are using, and good prediction for peak demand and how much energy we need. And also for the consumers, benefits is that the consumers can reduce the amount of the bills that they receive for the energy with the scheduling of the any electrical device in their house, such as washing machine, that it can work in a low demand of time of energy, which is cheaper. In the next slide, we can see different communication protocols and technologies that we are using in different parts of the smart grid. Mainly all these standards and communication protocols is similar to the Bluetooth that you have, all of you have maybe in your mobile phone. And one of the problems here, as you can see, there are many communication protocols and standards we are using in different parts of these systems. This comes with a research challenge that we call it interoperability. How this communication protocol can communicate to each other to transfer reliably the data between all the part of the smart grid. This is an open research area that many researchers at now it's working on this interoperability. In next slide, we thought that okay, we want to work on communication side of the smart grid, so we should consider compatibility and integrability of this smart grid communication system with next generation of wireless communication system. This research challenge are introduced by another European project, which is called METIS project. They are considered all research challenges for communication systems for beyond 2020. Among the many parameters they introduce, such as higher number of the data, higher number of the devices which will come connected to the system, and at the same time reliability, security, lower latency, and lower power consumption, and also higher mobile data volumes. Among all these two parameters, we are interested to reliability and lower latency to build ultra-reliable communication for spatial signals that we, for example, we use for control systems. In control systems, we need a very fast response and very highly reliable communication to transfer the data. What is the latency? Latency in communication systems is, it means that when we want to send, we have a request from the server, the mobile user send, for example, request of download to the server, and its response comes back to the mobile user. All these times, this round trip time calls as a latency. As an example, I have bring the LTE technology, long-term evolution latency. For example, for the situation from idle to active, it is less than 100 milliseconds, and for a small packet of data, it's 10 milliseconds. What is the requirement of a smart grid for latency? It's the minimum of the latency for a smart grid is 20 milliseconds. So if we can apply the LTE, we can achieve to that requirement. We can fulfill that. At the same time, what is the ultra-reliable communication? Current cellular communications can guarantee in 90% of the time connectivity for all the users. But they cannot guarantee the delivery of the reliable or high reliable of the transmission of the data. So this is very important part. We need, in some cases, that we should be sure that the data transferred peer-to-peer communication. And this comes this ultra-reliable communication for real-time signaling control systems that we should, in 100%, almost in 100% of the time, we should receive the data. Okay, the next question is that how we can achieve to this goal. This can be achieved by considering of different part of the communication systems. For example, what is the channel situations, channel for the communication, and what is the type of the information that we want to send. How long is the data that we want to send. All of this can address by different techniques to achieve to this goal. For example, if we have a bad channel, we should use different type of the modulation systems, or if it's better, we can use another type. Or for different type of the different lengths of the data, we can use the coding schemes. That's how we can code the long lengths and short lengths of the data. This is another, I have bring an example here. This work was done by some guys from BMW. It is for car-to-car communication. As we know, car-to-car communication needs high safety because it should connect to the traffic light, to other cars in the road, and other sensors in the systems. So it should bring us a high reliable communication for safety of the users. They introduced a factor that they called it availability indicator. This availability indicator estimates the channel situation. And when is the channel is in good condition, it's this availability indicator sends to both peer-to-peer this transmitter and receiver side of the communication link. For example, here. For example, here, for several transmission time interval, they try to find out what is the situation of the channel from the signal to noise ratio. And then when the channel is okay, this availability indicator sends for both sides of the transmission link. Then this transmitter tries first transmission time, but the receiver cannot decode the data, so it sends the no acknowledgement to the transmitter. And another retransmission happens in the next time interval, and in this time the receiver decoded the value, the data, and in this case it sends the acknowledgement. With this very simple link control, we can ensure that we receive the data and everything is okay. Mainly my research work is focused on evaluating of different type of techniques that we can increase the reliability of the communication link, especially in context of a smart grid. Thank you for your attention.
Okay, thanks again, Mehdi, for something from the other side of the power systems problem. So I'd just like to invite any questions from the audience. Yeah, Sahib, on you.
I'm not quite in the communication area, so I'm more looking at the power system and what is required from the communications of different types, medium kinds, and things like that. But the first thing I can say is you had so-called 3-9 security or availability requirements for telecommunication, and that's quite bad. Because 5 or 6, 9, 99.99999 reliability means approximately 1 hour in 10 years, if you look over the longer period, but it's the same as 1 second per day, if you look at it. So I would say 3 nines as the target reliability is not particularly good because the power supply systems, which are still not smart, I still haven't heard that some of the network operators said, my system is smart. So we're talking about the existing one, are operated with 5 or 6 9 reliability. And these are the existing one, not the smart one. The second thing I have here, based on that, and this is actually my question, goes as following. So if the security of this system is very important, then certainly there will be different applications for which we would like to have the ultra reliable communication, and these are critical, real-time, direct related to security and high-risk applications. So, do you have in this work some kind of target or application-specific requirement? Because you can make communication system very reliable, but they will be very expensive, and then perhaps you as individual customer who is not requiring that reliability will not be happy to pay the price for that. So that's the first question, technology or application-specific reliability. And the second one, you never ever mentioned what is known as the cyber security. So what if someone would like to use internet-based communication or single entry point communication to send a signal with clear intention to make harm?
I should divide the communication into different parts. As the first point is wired, it's wireless. In wired communication, yes, in many cases we can achieve to this high reliability, and at now they have it, okay? But the problem comes when we are using the wireless communication. And exactly because of that, many of the cellular communication companies that they are providing this facility for the people, because of the expensivity, because they cannot guarantee in wireless systems this ultra reliable. And because of that, we focus just for spatial, real-time signaling and control systems. We cannot provide for all the smart grid this high reliable or ultra reliable communication. So it means that in some cases, this fault monitoring and this kind of things that may be damaged, and the damage may be very expensive, we can pay more for this ultra reliable communication, but we can be sure that we achieve to this target.
There is application specific.
Yes.
The answer is yes. Second question about the cyber security.
The cybersecurity, almost I don't have any idea about the cybersecurity because this comes from computer science, and almost this is my second month of the PhD, and so I don't have any idea too much.
Okay, so maybe that's something to look into in your research.
Yes.
If you'd like to join me in thanking Mehdi again.
Thank you.
This production is brought to you by the University of Edinburgh.